In this video, we'll discuss the fundamental theorems of differentiation. Now, in our previous video, we learned that the slope of the tangent line is actually the derivative of the function with respect to certain value of x. And that value should be, the limit should be exist and it should be continuous to become differentiable. Okay, so today, let us provide a shortcut way of finding the derivative with respect to x using the theorems. And these theorems are actually taken from the slope of the tangent line. So there are cases, or we will provide the proof of each of the theorems to verify if it is coming from the slope of the tangent line. Okay, so the theorem number 1, we call this as the constant rule of differentiation. So when we say constant rule, the function should be in terms of a constant, which means there's no presence of the variable. It is purely a number without the variable x. So we call this as a constant function. So the derivative of this function should be 0. So the derivative of the function is 0. So we have to always remember that the derivative is 0 for the constant function. So to provide a proof, so we have to recall the slope of the tangent line formula, or the derivative of y with respect to x in terms of the limits of the function, which is the function of x plus delta x minus the function of x all over delta x. And delta x must be approaches 0 in order to become the derivative of this function. So since there's no, our function has no variable of x, okay, there's no variable of x, so therefore the function x plus delta x is simply a c, while the function of x is also c. So we have to subtract c minus c. The answer is always equal to 0. So therefore, this is true that the derivative of the function is 0. So for example, suppose we are asked to find the derivative of the function of 150. So since there's no variable x here, so we can treat this as the constant function. So the derivative of that is actually 0. Very easy. So suppose we are asked to evaluate this derivative, wherein we are to find the derivative of the log of 1000 with respect to x. Now again, there's no variable here because the indicator is x, so and there's no variable x in the presence of the function, so we can call this as the constant function. Then it follows that the answer is always equal to 0. So another example is if y is equal to 3e squared. Remember, e is the exponential constant, so therefore this is a constant, 3 is a constant, and 2 is the exponent of the e. So if you are asked what is the derivative of the function at the value x, okay, the value x, then the answer is always 0. Why? Because this is constant function. Okay, so therefore, if this is only the derivative of the function with respect to x, but with respect to 3, so since there's no variable here, the answer is still 0. So the derivative of y with respect to 3 is also equal to 0. Another example is, look at this one. The function is y is equal to 2wz divided with 2ab. Now remember that our function is y, okay, and our indicator is x. Now since there's no x here, and this variable also, there's no indicator that this one are the function of x, then it follows that this can be treated as the constant, no? Otherwise, if this is specified as the z as a function of x, then we cannot treat that as a constant. But in this case, there's no indicator that these literal variables are related to x. In this case, everything can be treated as constant, so the derivative must be 0. It must be 0. Okay, that's it. Very simple. Now, for the second theorem, theorem number 2, we call this as the power rule of differentiation. So, the power rule is actually in the form of the function of x raised to n. So, remember this, x is the domain, okay, and this is purely x. And raised to a power of n, where n is a real number. So, any real number, which means that if we have the variable exponent here, then it is not within the scope of the power rule. It's beyond the limits of the power rule. So the limitation is, this is purely x, okay, purely x, which is this one, or any variable which is the same as the variable inside the function. So then another is, n should be a real number. So any real numbers. So infinite number is not considered. And in the presence of the variable also, which is a function of x, then it is actually beyond this power rule. Okay. Now, what is the derivative of x raised to n, which is the power rule differentiation? So to answer is, you can imagine that you have to drop this just into x. So remember, this is 1. So it is simply as 1 times n, so it becomes n. And the exponent, which is the real number, should be subtracted by 1. That's it. This is now the derivative of the function. Theorem number 2. Again, to evaluate the function which is actually in the boundary of the power rule, then all you need to do is to drop the n here, adjust into x, or it's simply as 1 times n, is set, and n should be subtracted by 1. As okay, that will be the derivative. So for example, suppose we have the question, find the derivative of the function, and the function is x cubed, and we are about to find the derivative at x is equal to -1. So all you need to do is to find first the derivative. Take note, find the derivative first with respect to x, then after using power rule, after that you have to substitute the value of -x. This is the boundary limit actually, and this will be the question, specific derivative. Okay, so applying the power rule, so for your solution, take note, our x is the domain, x is to x, and the exponent is 3, so this will be our n, and this is a real number. So all you need to do is to drop this 1 times 3, or drop the 3, so becomes 3x, and this should be subtracted by 1. That's it. So we have 3, whatever exponent, put it here, adjust into x, then subtracted by 1 always. Always subtract by 1. Every time that you are differentiating, subtract it by 1. So you are decreasing actually the degree of the function. So from third degree, this will become second degree function. So the second degree actually is the derivative of the x cubed, or the function. So this is first order derivative of the x cubed. Okay, that's it. So this is now the derivative of the function x with respect to x is 3x squared. Now, finding the derivative at -1, so substitute the value of x here, which is -1, and evaluate. The answer is, by the way, this is -1. By the way, the answer should be, this should be +1. Kindly correct this one. This is positive, because negative times negative becomes positive. So change this to positive. So we have 3 times 1. The answer is 3. That's it. That's the answer. Now, the proof. Is it true that this is the derivative of this x raised to n, or the power rule? Then let us verify. We will verify now using the slope of the tangent line formula, or the limit of the function x plus delta x minus function of x over delta x. As delta x approaches 0, the derivative of the function with respect to x. Okay? Now in this case, again, we have to recall our previous video that remember, we have to substitute the function of x plus delta x, and the given is the function of x only. So all you need to do is to replace this, okay, replace this x with what? X plus delta x. So therefore, this will becomes what? X plus delta x raised to 3. Okay, so we have to replace this and replace also this one. And that will be the value of the function of x plus delta x. And this one, the function of x is the given function. So replace this with x cubed. While this one should be x plus delta x raised to 3. That's it. So this one is simply as delta x. Copy. So the limit as delta x equals to 0. So this is now the function of x plus delta x minus the function of x. Now all you need to do is to expand this one. Okay, so that the purpose of expanding this term is to remove the terms that has no delta x, because we want take note that we cannot evaluate the limit here because this is delta divided by delta x, and 0 is actually cannot be divided in the fraction, so no zero denominator. So in order to do it is to remove this one. So the only way to remove the delta x is to expand this one, then simplify. So if you simplify this one, this will becomes 3x cubed. Okay, recall your algebra. X cubed plus 3x squared delta x. So the exponent is decreasing, and this is the coefficient of 3. Then we have the first degree delta x plus 3 x is keep on reducing, and we increase the delta x squared plus delta x cubed. So this will be the expansion of x plus delta x raised to 3 minus this one. Okay, now we can notice that we can cancel the x cubed. So therefore, we have only, by the way, we can factor out the delta x because common. Okay, common delta x, so we can remove 1 delta x outside. So this becomes 3x squared plus 3x delta x. This is delta x squared, remember. So we remove 1 delta x outside. This will become 3x delta x plus this is cubed. So remove 1 delta x becomes x squared. Now in this case, we can now remove the denominator that can provide undefined. So with that, you have to evaluate the limit now. So substitute 0 in the delta x. This will become 0. The whole term becomes 0. And this one, 0 squared is also 0. So what we have only is the x squared. And okay, so evaluate the limit. This will become 0 again. And substitute, the answer is 3x squared. So take note that this answer is the same as this one. So in other words, we will not use the formula, the slope of the tangent line. Instead, to have a shortcut way to solve for derivative, then use, because this belongs to the power rule. Again, this is only limited for the power rule. Take note that we expand this 3 times, this binomial, so this is a real number. If this is non-linear or the non-real number, then we cannot expand that in this case. So we cannot eliminate this one, and we cannot remove the denominator delta x. So that's why we call this as power rule. So always remember that n should be a real number. That's it. Okay. Another example. Suppose you are asked to find the derivative. Now this time, look at this one. The function is 1 over square root of x. If you notice, this is not actually in the form of x raised to n. Okay? So take note that the power rule is intended only for the exponent. Okay, the base, which is the same as the indicator, x to x, and raised to n, and n should be a real number. In this case, there's no exponent. Okay? Now the question is, can we apply the power rule using this of this function? The answer is yes. Why? Because this function is transformable into the power rule. So this can be transformed in such that we can change this and change this in the form of the power rule. How? Okay, now take note that x square root of x is the same as x raised to 1/2. Okay, so radical can be expressed in terms of exponential. So this will become 1 over x raised to 1/2. Okay, so for our solution, so this will become 1/2. The derivative, by the way, this is the derivative of the function, and the function is this one. But this one can be, again, from radical form transformed to exponential form. Okay? Now, take note the lobe exponent, we can place it upward. in the numerator side. So if we transfer this to the numerator, the exponent becomes negative using the law of signs, the law of exponent. Okay, so this will becomes x raised to negative 1/2. So notice now that this is x and this is x, variable x. Okay, and negative 1/2 is actually considered as n. Why? Because negative 1/2 is a real number. So always real numbers are negative numbers, decimals, zero, positive numbers. Okay, so all real numbers are considered. So therefore, we can now apply the power rule. How? Use the same process of the power rule. You have to drop this one or multiply the coefficient of x by the exponent. So 1 times negative 1/2 is negative 1/2. And subtract this negative 1/2 by 1. Okay, so this is it. This is now the, after dropping, you have to drop this one just into x. And this will become negative 1/2. And the exponent, which is our n, always subtracted by 1. So with that, we can now simplify, and the result is actually the derivative of the function with respect to x, of the 1 over square root of x. So negative 1/2 is negative 3/2. Okay, so negative 3/2. Now take note that negative exponent can be changed to positive. Putting it down or under denominator side, this will become positive 3/2. And the whole terms is actually a negative number. Okay, so this is not the answer because the simplified doesn't have the radical exponent. Oh no, fractional exponent. So all you need to do is to return that into radical form. This will become 2 square root of x cubed. Take note that in the exponent, the denominator is the index of the radical, so that's why this is square root. And the exponent, the numerator is the exponent of the radicand. So this will be square root of x cubed. Now this is not the answer again because no radical expressions under denominator. So all you need to do is to what? By the way, we can simplify this one, because x cubed, remember, x cubed is x squared times x. So the square root of x is x. And we have the square root of x. So the x square root of x is equal to the same as x square root of x cubed. Square root of x cubed. Okay. Now again, there's no radical in the denominator, so all you need to is to rationalize. So you have to recall again your algebra. To remove the radical under the denominator is to rationalize. This is 1. This is the rationalizing factor. So if you multiply x times x, the answer is square root of x times square root of x. The answer is x. So therefore, in this process, we are able to eliminate the radical sign. So simplifying, we have 1 times this 1, so we have square root of x over this will become x squared because this is x and the square root of x times square root of x is x also, so 2x squared. So the answer is negative square root of x 2x squared. Now take note, this is not the answer because we are asked to find the derivative at x is equal to 2. So all you need to do is to substitute the value of x here. So replace with 2, replace this with 2, and the answer is negative square root of 2 divided by 8. And this is the answer. Okay, that's it. So the theorem actually applied. No, do not. By the way, before going to use the power rule, always examine, because sometimes function can be transformable into a power rule. So use your algebra. So without your algebra, you cannot solve this one. Okay, so then number 3 theorem, or theorem number 3 is a constant multiple rule. So what do you mean by constant multiple? So we have the constant and multiplied by a function. So if we have a constant, and a function in a form of factor, then we call this as a constant multiple rule, where c here is the constant and we have this function. So the derivative of this cannot be 0, no? Because only the constant has the derivative of 0, but a constant multiple is not a 0. Okay, so all you need to do to find the derivative of a constant multiple, or the constant times the function, then all you can move outside the constant, because actually this will not be affected during differentiation, so move it outside and focus only on the function of x, because this is where that has the presence of the variable indicator here. Okay, so that's it. So apply the previous theorem, theorem 1, theorem 2, then after that, after obtaining derivative, that's the time you have to multiply that by c. Remember, c here cannot be 0 because it is a constant multiple. So, but it was not affected during differentiation process. Okay, so then that's it. That's the constant multiple. So the key factor here is you have to move outside the derivative operator, differential operator, the constant c, because c cannot be affected during differentiation. Okay, so it is actually as is. So for example, suppose I have this one. Find the derivative of the function which is equal to 5 cube root of x squared at x is equal to 2. So what will you do? So for your solution now, take the derivative because you are asked to find derivative. So dx of this function, the whole function is 5 cube root of x squared. So all you need to do, since 5 is a constant, okay, we can move 5 outside the derivative operator, differential operator. Then we have now purely as the x, derivative of x as with respect to x of the function x raised to. Take note that radical can be converted into exponential form or transformed to exponential form, wherein we have the, because when you transform the radical, the exponent becomes fraction. So all fractional exponent actually transformable to radical form. So take note that the denominator of the exponent is the index. So that's why we have this cube, and we have the numerator is the exponent of the radicand. So you have to recall your law of radical, okay, or the theorems behind the radical expressions. So therefore, with that, this can now be treated as the power rule. Take note that this is x and this is x, purely x, and raised to 3/2. 2/3. 2/3 is again a real number. So this is x raised to n. So then power rule can be applied. So same process. So take note this is 5 is you have to preserve the 5 because again 5, which is a constant, cannot be affected in the differentiation process. So all you need to do again here is to drop the 2/3 here and subtract this by 1. So that's it. So the 2/3 is actually becomes now another constant multiple, and x raised to 2/3 subtracted by 1. So be careful on your subtraction of the fraction. So this is 2/3 and this is 1. So 2/3 becomes negative 1/3, and this is 5 times 2 becomes 10. Okay, so again there's no negative exponent, so all you have to do is to put it down the denominator position. So this will becomes 10 raised to 3 x raised to 1/3 becomes plus. Okay, from negative becomes positive. Now take note that answers should not be expressed in terms of exponential form. So all you need to do is to change that into what? Into radical form. Becomes, and remember that the denominator is the index, so this is cube root and this is 1 x raised to 1. Okay, now again this is not the answer because remember that what? No radical under denominators. All you need to do is to rationalize. So you have to think of rationalizing factor that can remove what? That can remove the x cube of x. Cube root of x. So the only way that we can remove this one is we have to multiply this with another radical expression with index 3. Okay, and the exponent, remember this is 2. So therefore the rationalizing factor should be cube root of x squared. Okay, so this is actually the rationalizing factor is taken from the behavior of the denominator. So you have to think of a number that you can eliminate the radical sign. So the only way to remove the radical sign is to multiply this with the same index cube, and you have to raise this by 2, because when you multiply this applying the theorem, the principle of the radical, then this will be multiplied. So this will becomes x. X times x squared becomes x cubed also. So the cube root of x cubed is actually x. So with that, we are able to obtain remove the radical symbol. So since we need to multiply the denominator by this factor, then you have to do it similarly under numerator, so that this expression will not change. It's a number, so it will the same, because this is 1. Remember, this is 1. So multiply all denominator becomes, this is 10. You just copy 10 cube root of x squared, and this will becomes what? This will becomes 3x. Okay, because we cannot eliminate the cube root. That's it. So from this, transform into this form. So there's no radical expression. So with that, this is actually partly answer. But take note that you are asked to evaluate derivative at x equal to 2. And this 2 is exists on this function, then continues also at this function, because this is part of the domain. Okay, so then substitute the values, replace 2, then continue simplifying. We have 5. Okay, 5 cube root of 4 over 3, because take note 10 and 2 can be divide, so it becomes 5 thirds cube root of 4. That's it. This is the answer to the problem. Theorem number 4. The theorem number 4 is called as the sum rule. What do you mean by sum rule? When we sum rule, a function is composed of many terms, and it was actually in the form of plus or maybe minus. So when we sum, algebraic sum. So what will happen if we have 2 or more functions and added and subtracted and form as a single function? So our function is actually this one, y, which is equivalent to a function of x, and we have plus or minus another function, gx, plus minus again, it can be plus or it can be minus another function, and so on. So what will happen if this is our function? Now how will you obtain the derivative of the function which is in the form of plus or minus of the functions? So to do it is very easy, no? So to find the derivative of this function, all you need to do is you can actually, it is just like a distribution of the operator. So you can distribute the operator in each term here, or in each function, then take the derivative individually. You can do it. But remember, this is not actually a distribution process, because remember, this is an operator, this is not a factor, but it is just like that you are distributing which means that the derivative can be penetrate inside its term. Okay, so with that, look at this one. We find the derivative of this function of x, then plus or minus the same operator derivative of the gx, and do it in the its function of x, plus or minus. Then with that, after this, use our previous theorems. So examine if you can apply this one. If that function can be theorem can be applied to this function, then go. Okay, then simplify further. That's it. That's the sum rule of differentiation. By the way, if you evaluate this value, this is actually following the slope of the tangent line. It follows the slope of the tangent line formula. So everything are taken from the slope of the tangent line formula. Now, for example, suppose you are asked to find the derivative of the function, and the function, look at this one. Our function of x is 3x cubed plus 5x squared plus 2x, negative 2x plus 6, and find the derivative at x equal to 1. So all you need to do is to find first the derivative of this function with respect to x, so first order derivative, and after that, use, individually find the derivative, distribute the operator, then go. Continue to the differentiation process. Okay, so like this. So each term has the operator of the x, or the derivative of the function with respect to x. So with that, you can now remove, take note, this is coefficient, so using the constant multiple, then you can penetrate the derivative operator here. So this is now power roll. Okay, do it the same here. This one, okay. Then this is constant roll. This is 0. So with that, this is it. So the constant was removed 5 or move outside the operator. The 2 is 1. Then therefore this one is constant. So apply power roll, power roll, power roll. By the way, this is power roll. Why? Because this is exponent 1. So this is still power roll. So you have to divide it by multiply, drop the 1, then subtract 1 minus 1. 1 minus 1 is 0. Raised to a number becomes what? Number raised to 0 is always 1. So therefore this is 1 actually. The derivative of x with respect to x is 1. And this one is 0. So with that, this is now following the power roll. So it dropped the 3. So it becomes 3 times 3. Becomes 9. Take note. Becomes 9. And this is 2 minus 3 minus 1 becomes 2. So second degree. This is second degree. This will become first degree because it's 2 minus 1. And this is 2. So 2 should be multiplied by 5. Okay, then 2 again, negative 2. Constant multiple. 1 minus 1 again. This is 0. So this is 0. 1 minus x raised to 0 is 1. So the answer is 2 actually. Okay. So this is it. 9x squared. 10 raised to x. 10 times x raised to 1. And this is 2. Because this is. And this is. By the way, this one. So this is raised to 0. So simplifying again. This is 9x squared. And this is 10. Do not use 1 here. Because this is understood to be 1. And this is 2. Okay. That's it. Now, replace x with 1. And the answer is 17. Okay, so that's it. We are able to find the derivative of the function of the two or more functions added and subtracted. Okay, so this we call this as the sum rule of differentiation. Number 5, we have the product rule. So what will happen if we have the functions in the form of product? So what is the product rule of differentiation? So the function now is in the form of, look at this one, the function is a form of u, v. But take note, u is not a constant, v is not a constant. Why? Because u is a function of x, and this is the operator, variable indicator. So v is also a function of x. So therefore, we cannot say that derivative of this is 0, because there's no x. But remember, there's a note here that x is a function of u is a function of x, and v is also a function of x. So with that, this forms a product rule. Okay, product rule of differentiation. So how will you find the derivative of a product rule using product rule? So all you need to do is look at this one. First is, by the way, this is not the same as the sum rule that you can take derivative of that, then take derivative of this. No, you cannot. This is different. Okay, we have a special rule of for the product only. So for the product, forming product, meaning this is just like function of x times g function of x. So with that, all you need to do is first is to copy the first factor, then take the derivative. So meaning you have to take derivative one at a time. You cannot take derivative two at a time. So first is you can choose any of this, preserve it, then take derivative of the other. So with that, look at this one. So you can treat first factor to be a constant number, then you have to differentiate the second factor. Or you can reverse this one. You can reverse the process. So the derivative of uv is v u dv, which means that you have to differentiate the v. Then after that, add here, then reverse. So since we preserve the u, the next round is to preserve v, then take derivative of u. So it should be what? The derivative of uv is v u dv plus v du. So okay, so one at a time. But take note that each term here, or each factor, was differentiated. The first term, v, was differentiated, but we copied u. The second term, the u was differentiated, but we copied v. Take note, we just copied whatever expressions under the v in this term. And this one, we copy everything what is in the u function and we differentiate the v, which is a function of x. Okay, that's it. As simply as that. This is the product rule. Okay, now what will happen if there are 3 or more? So this is only 2 factors. So will it works on 3 factors? The answer is yes, 2 or more. It can be applied. Now remember that you have to apply the one at a time. So you can only differentiate one at a time. So since we have 2 factors here, we have 2 terms because one at a time. So for 3 factors, we have 3 terms because one at a time. If we have 4 factors, we have 4 terms of the answer. So for example, this one, suppose you are asked to find the derivative u, v, w. All of them are a function of x. U is a function of x, v is a function of x, w is also a function of x. Then all you need to do is to differentiate one at a time. So if you decide to differentiate w, then we have w, dw, then copy the 2 factors. One at a time. Then in the next term, since you're already done with w, you have to decide now whether to choose u or v. Nothing to worry. Any of this. Now if you decide that you need to differentiate next the dv in the second term, so dv will be differentiated, then copy the other term. And you have to copy the u and v. Okay, u and w. So finally, because there are 3 factors here, so check there should be 3 terms also. For 2 factors, 2 terms. But 3 factors, 3 terms. Now, finally, we will differentiate the u. Okay? Because u will be the last to differentiate. So, copy the other 2, which is u and w. Okay? That's it. So, for example, suppose I have to, you are asked to find the derivative of the function, and the function is x plus 2 times x minus 3. Then, okay, find the derivative. This is now forming product. Okay? Find the derivative at x equal to 1. So, with that, first, find the derivative with respect to x, then after, substitute 1 to provide the complete solution of the problem. Okay? So, this is under the product rule. So, one at a time, you can choose any. So, if I decide to differentiate first the x minus 3, then this must be preserved as s. So, we have this one. And then, in the second term, preserve again because this is already done. We have already done differentiating the second factor. Then, preserve it in the next term. Then, we have to differentiate the first factor. That's it. So, one at a time. So, with that, apply the basic our previous theorem. So, this one is sum rule. Derivative of x, take note, is, what is the derivative of x? Is 1. And this one is 0. Okay? Now, take note that x here, in the first term, x plus 1 is already part of the answer. This one is also part of the answer. Do not differentiate because in this first term, you are only to differentiate the x minus 3. And the answer is 1. This one, differentiate, okay? Sum rule again. So, this is 0 and this is 1. So, the answer is, look at this one. By the way, you do it in a step by step. So, take derivative of that. Take derivative of that. This is it. So, then take note, this is part of the answer. You just copy. Then, derivative of x, sum rule, derivative of 2. So, with that, we can easily take note, this is identity or this is raised to 1. So, this is 1. Because x follow the sum rule, okay, or the power rule. And this is constant, so 0. So, just copy this one, x minus 3, copy. So, just copy the coefficient, the derivative. And this one is another constant, so this is 1. And this is 0. So, simplify again, reduce. This will, actually, 0 can be eliminated here. So, we have purely x plus 2, and this is x minus 3. X plus 2, x plus minus 3. So, then, combine. So, we have 2x minus 1. Then, substitute the value of x equal to 1. Then, that's it. We have the answer. The answer is 1. The derivative of the function of x plus 2, x minus 3 at x equal to 1 is actually 1. And take note, this is the slope of the tangent line. Remember, the derivative of the function with respect to x is the slope of the tangent line. This is the slope positive, so open to the right, at x is equal to 1. Okay, so another example, suppose we have 3 factors. Okay, so do it consistently as long as you did not violate the rule of the theorem number 5 and other theorem, then you will arrive the correct answer. So the keyword is 1 at a time. So preserve the 2. Then take derivative of the other the 3 or any of this. So 1 at a time. So there are 3 terms. So to find the derivative, we have the first term. So just copy the first term. Then take derivative of the 2 factors. First 2, copy the first 2, then take derivative of the third factor. And after that, since it's already done, so choose any of this. So if I choose this one, 2x minus 3, then copy this one and this factor. Okay, that's it. We have to differentiate. This is only second term, so proceed to the last term. Third term is, we already have this second and third, then finally we will find the derivative of the first. Again, you can choose any. There's no specific order in this case. You can choose as long as 1 at a time. Now always remember that the factors that you copied is already part of your answer. So all you need to do is to evaluate the operator. You are, in this case, you are asked to evaluate the derivative. So evaluate using our theorem. This one also is part of the answer, but take note, separated by plus. So you have to evaluate this first. After that, you can multiply these 3 factors, the result. So do it the same. Okay, so take note, this is power rule. So 3 times 4 equals 12. So subtract it by 1, so x squared. So I provide you a shortcut way. So drop this, 3 times 4 becomes 12. And subtract by 2, from third degree becomes second degree. This one is copy. Remember, we copy the first 2 factors. Then copy these 2 factors again. It's part of the answer. Now this one, the answer is what? The answer is 2, because the derivative of x is 1. So the coefficient is 2. So 2 times 1 is 2. And 3, take note, is 0. So there's no number here. Then copy this one, and this is it. This one. The derivative is 2, because you have to drop this. 2x, 2 minus 1 becomes 1, so 2x. And this is 0. That's it. Then you can simplify. Okay, expand, multiply. So the algebra now is very important. So you have to multiply this one. X squared plus 2, 2x minus 3. The result will be multiplied by 12x squared, and the answer is this one. Okay, 24x raised to 5, 36x squared, 48 raised to 3 minus 72x squared. So this is actually 1, 2, 3. This is the result of these 3 terms here by multiplication. Now this, we have also another term. Multiply this 3. The result is this one. And finally this 3 again, and the result is this one. Okay, so with that, substitute x with negative 1. By the way, simplify it again if you do it. This is the simplest form, the above expression. So then after that, we can now easily substitute the negative 1, and we provided 237. So can you double check this one if this is correct? So the most important is the process actually. So you have to review your algebra here. So again, be careful with your algebra, because any mistakes along the way, you cannot provide this answer. So always bring your ability in simplification. So always apply the law of algebra correctly. Follow the law of algebra. Okay, last theorem. Basic. Take note, we have 6 basic theorems. The quotient, if we have the sum, we have the product, we have also the quotient rule. So they are actually different treatment. We cannot equate the sum, the product, and the quotient. So what is now a quotient rule? So what is a quotient rule? a quotient rule is applied to a function if you are forming numerator and denominator. So in this case, u over v. But take note, u is a function of x and v is also a function of x. Okay? So therefore, anything na mo form na ni, all of them are function of x, then we call this as a quotient rule. Now, if denominator is not a function of x, then you can skip this method also. You can skip this method, but you can still use, but treat that as a constant. Okay? So, okay, it's up to you to choose whether to use, if this is related to x, any of this non-related to x, then you can use the previous theorems instead of having quotient rule. Okay, so what will happen if we have the function which u as a function of x and v is also a function of x? So this is purely applied by the quotient rule. Okay, so with that, to find the derivative is, look at this way. Now first is you have to preserve the denominator. So take note, the use preserve means do not take derivative. So you have now to take derivative one at a time again. One at a time. So this is different in the product rule. So memorize this. You have to preserve first the denominator. Okay? Then take the derivative of the numerator. Then after that, subtract it. Okay? So I have followed. Subtract, not add. Then after that, preserve the numerator. Then take the derivative of the denominator. So it should be in order. No, you cannot change the order because you are subtracting, you are not adding. You are not adding. And unlike in product that we add, so there's no sequence. So you can choose any. In this case, first is, I will repeat, preserve the denominator, take derivative of the numerator. Then subtract it, preserve the denominator or numerator, then take the derivative of v. So it should be in order. Now, natin the answer. Divide everything. Okay, divide everything. The result should be divided by the square of the denominator. That's it. This is the answer. Okay. So therefore, the derivative of function forming a fraction which belongs to quotient rule, it provides an answer of a fractional answer of the derivative. So let us repeat. We need to preserve first the denominator, so copy. Okay, then take derivative in the numerator. Then minus, it should be u, which is, now we preserve the denominator and numerator, then take derivative of the denominator. This is one at a time, but we have the order. So you cannot change this, because when you change this one, then it will provide different answer. Because take note, this is negative. Okay? And everything should be divided, whatever value here, v, square it. That's it. Everything, whatever present under the denominator, square it, and that will provide the complete answer of the question. Find the derivative forming a quotient rule. Okay, that's it. This will be the answer. So if you memorize this one, this is v du minus u dv divided by v squared. Now in the product rule, u dv v du. That's it. No denominator. But in the quotient, we have the denominator. Square. No derivative under denominator. The answer. Just square whatever present in the denominator. Okay. So for example, suppose we are asked to differentiate the function, and the function is x squared plus 2 all over 2x minus 3. So what is the derivative of this function at x is equal to 2? So first, find the derivative with respect to x, and after that, substitute the x value. Do it. So, follow. Preserve the denominator again. Preserve the denominator. Then differentiate the numerator. Okay. And after that, subtract. Okay, subtract. Preserve now the numerator, then differentiate the denominator one at a time. But it should be in order. Preserve the denominator first. Okay, then after that, do the derivative of the numerator. Then change the order. Then whatever under denominator, you have to square that. Again, reminder, there's no derivative under denominator. So in this case, you have to evaluate this one using sum rule, then after that power rule, then constant rule. Do it the same, this one. But this one, x squared plus 2 and 2x minus 3 are already part of the answer. So just wait until evaluating this one. The result here should be multiplied here, then combine. The result, derivative here, should be multiplied this factor, then combine. Then take note, they are separated by this minus, so you have to do the law of signs. Then expand, or do not, by the way, do not expand this one. All you need to is to compress numerator. Then find out if you can subtract, you can cancel this one. Okay, because if you expand this, your expression becomes complicated. So you have to compress. The only the way to compress is to expand the numerator, then combine. Okay, combine, then factor the numerator, then find out if you have something to cancel under the numerator. If none, then that's it. That's the answer. Okay, so do it. So this one is copy. So this is 2x, and this one is 0. Take note. And this one is copy. This is x squared plus 2. And derivative here is 2. And this is 0. So therefore, this is purely what? Distribute. This becomes 4x squared. And this is minus 6x. And this one is 2x squared, then 4. Okay? That's it. Remove the governing symbol. The numerator becomes 4x squared minus 6x minus 2x squared minus 4. Then, by the way, you can combine this one. Becomes 6. Okay? So then, with that, okay, we can factor out 2. But look at this one. You cannot cancel the numerator. So actually, you can... Wait, that's it. That's the answer. If you are asked to find the derivative. But take note that you are asked to find the derivative of 2. So all you need to do is to substitute the values of 2 in the x variable. So then evaluate using algebra. Then the answer is negative 8. So review this one if this will arrive negative 8. So this is the process of finding the derivative under quotient rule. So okay. By the way, there are two options here. Now take note that we have the lobes of exponent. So actually, you can put the place this under numerator, and if you have negative exponent, then you can apply the product rule. Okay, product rule. So you can escape the quotient rule, but still you will arrive the same answer. Okay, so that's it. That will be those are the theorems of differentiations. So the next video, we will introduce another topic. Okay, so that's it.